Hi, this is Mark Pauls. I'm your instructor for 710, and this is a short video over assignment 7.1. We are in week 7, getting close to the end. This week we have regression analysis. So if we do a quick review over what we've done the past couple weeks here, we started off understanding descriptive stats. We moved into correlations. I believe that was about week 4. Week 5, we talked about t-test and 2 sample tests. So, an increase, decrease, comparative of one sample to a known value. So we worked on 2 samples in week 5. In week 6, we talked about ANOVAs and the various kind of ANOVAs, and that's what happens when you're comparing 3 or more. Our final one this week is regression. Now, I like this the best. This is prediction. This is taking the data you have and trying to predict an outcome, which is my favorite portion. Now, again, we are covering a ton of stuff in a week. And actually, we're not covering a ton of stuff. We're covering the basics in a week. You could take multiple 16-week courses on regression. It gets deep. You guys don't need to do that. Leave that for people like us. So we're gonna touch the basics. So we have 3 questions. Like I say, right now we're heading down to our prediction group. We have 3 questions in our regression analysis that will touch on 3 different types of regressions that we're looking at. Okay? So first, we'll handle this one the same that we've handled the others. I got a little cheat sheet for you, and we'll walk through the PowerPoint. That PowerPoint's phenomenal. Make sure you keep track of that. Okay? So research question number 1. Does BMI predict self-esteem? Okay, so we want to know from the data that we gathered, can we predict BMI, or can we predict the self-esteem from BMI? So if we go to our trusty little chart, we are doing a prediction. Okay, so we're going to go down to slide 18. Really, we have 3 tests that we're going to study. If you are predicting one scaled value to another, meaning your dependent value, what you're trying to predict is a scaled value, and you have one independent variable, this is a linear regression, which is what we're having here, okay? We've got BMI, pre-BMI, as the independent variable, and self-esteem as a dependent variable. Both are scaled values. We're running linear regression. Here's how we do this in SPSS. We're going to go to Analyze. We're going to go to Regression. And we'll go to Linear. When the box comes up, we are going to enter our dependent value here. Now, the dependent value is what you're trying to predict. We're trying to predict self-esteem. So self-esteem will go here, and we're using pre-BMI to do the prediction. So that's going to be the independent. Pre-BMI goes there. Now, not so much in linear, but there are methods that you can use as you work through a regression to determine whether or not these values actually do have a correlation to them. And it always goes back to the significance level. Okay, when you run this value, when you run this test, you're going to come up with an analysis chart. Okay, and in this case, only pre-BMI is going to have a significance value. You can set it up here to where, again, we're making predictions, so we're making best guesses. You can do a confidence interval where 95% of the time you feel like your value is going to fall in this range. You're just making best guesses of what you're doing. So run this process, hit your statistic or hit your OK, and then what you'll need is when you report, you'll have a model amount. Why don't we go ahead and run this one? Okay. What you'll end up with is something like this. The model summary, which really means nothing to you here, when we get down the road, or if you run this with a lot of variables, okay, you're going to have some variables that correlate with each other, and they run together. You don't need all the variables in there. The model summary is going to say, if we took all our variables, put them together, how much better is it than if we cut this up? Okay, can we do the same thing and not use all our materials? Well, in linear regression, we don't have that. We've just got the one, and it's pre-BMI. And you can see here that the significance level is low, less than 0.001. So pre-BMI can be considered a significant factor in predicting self-esteem. This is the information you need right here. That's what tells the tale. Then your prediction equation would be self-esteem equals your constant value. So equals 100 minus 0.95 times pre-BMI. That is your prediction model. Self-esteem equals 100 minus 0.95 BMI. This constant is kind of the general, it's hard to explain on this one. It's saying if you had no BMI, you're going to start at 100. That's where you're going to be for self-esteem. Okay, so that's just if we have a nil reaction or nil rate, that's where we start from. So every additional a unit of pre-BMI brings down a person's self-esteem 0.95 points. Okay, that's how you run a linear regression. Let's move to our second. Our second question is, do age, education level, and self-esteem predict BMI? So we go to our regression PowerPoint. We have more than one independent variable, all in scaled data. All right. So, or the dependent variable is scaled, and we have more than one independent variable. So what we have is age, education level, and self-esteem trying to predict pre-BMI. So we got a scaled value here. We've got more than one independent. We're going to run a multiple regression, and we use the same type of process as what we did with the linear. We go analyze, regression, linear. We can get rid of the stuff that we just put in. Now we want what were they? Age, education, and self-esteem to predict pre-BMI. So the pre-BMI is going to go right up here. Now, this method here, run a stepwise. And what that does is it will look at each of the combinations, all three together, each one by itself, pair of age and education, education and self-esteem. It will run all of them to see, it's possible age may not have any bearing on pre-BMI. It may not matter. Kick it out of the model if it doesn't make a difference. Same goes with education, same goes with self-esteem. We just saw from our last model that self-esteem and pre-BMI are matched. I think that's what we had, yes. So we know that there's going to be something there. We don't know about the other two. So when you put in stepwise rejection, or stepwise progression, you're going to come up with a variety of information, but you're going to have a box that says variables removed, and then a box that has your model or your coefficients. Okay? Take a look. Let's see if we can scroll down here too. I don't think I have it. Maybe I do. Okay. So if we look up here, it's going to tell us what we keep and what we remove. The only thing that was kept was self-esteem. Age and education had no significance as a predictor on self-esteem. Now, if you want to see how they actually value, change that scope back here, leave this as enter. If you do that, you'll see all three no matter what they are. Stepwise will test them all and take out anything that doesn't matter. Okay? Then it'll tell you what you removed. Actually, here's the enter right here. And you can see that there was no significance with age and education. So here is your final model. Pre-BMI equals 105.263 minus 1.053 times the value for self-esteem. So if someone gives you their self-esteem rating, whatever it is associated in the data, you can kind of make an educated guess as what their pre-BMI was. Okay? So again, the higher the self-esteem, how would that be? Probably the lower the pre-BMI, which makes sense. A healthier person. Okay, last one on the list. Close out of that one. On the last one, are age and BMI predictors of job satisfaction? Now, what's key here is our dependent variable is nominal. We've got a nominal dependent variable. We've got multiple independent variables. But since this is nominal, we're going to use logistic regression. So here's how we go about this, if I can find my spot here. We are going to go analyze regression binary logistic. Enter your two independent variables here and your dependent variable here. For the test, this is the same type of thing. If you hit enter, it's going to create a whole model. It's going to include everything, whether it matters or not. What I choose is the Wald test. To me, that's my favorite. Okay? And again, this is more information than what you need. But what you need to understand is that as you run a regression, there are some variables that don't matter and need to get kicked out so it doesn't make it a mess. Okay? Run a forward Wald, and this is the same type of situation as last time. I'm not going to give you the answers on this one. I want you to find it. But you'll be able to look through and see how a whole model test compares to when it's cut up. And we want to use the model that's cut up. We want to take out the independent variables that don't matter. That's the purpose of a regression, is to create the best possible model for prediction without making it messy. Additional variables, if we don't need them or if they don't add additional benefit to the model, get them out because it becomes a mess. We want the most efficient, most accurate model we can find. There are sometimes that you can have two values that really lend the same thing. Like you could go age and weight for young people. Okay, as they age, their weight's going to increase. Well, both those, they may add something intricate to the model. They might not. If they run together, that's called collinearity. If you have too much collinearity, you don't need both those variables in there. Okay, you can get one of them out and simplify the model. I hope this all makes sense. 3 questions this week. Please ask questions as needed. This is the process that we have. Like I say, got questions, let me know. Thanks. Have a great day.